Hello dear students, welcome to the second video lectures of Unit 3 of Engineering Mechanics, that is equilibriums. Okay, in first video lectures we have discussed the some basic theoretical background, that is the what is meant by equilibrium, what is free-body diagram, how the procedure to be followed for drawing the free-body diagram, types of supports, 2 force member, 3 force members, and Lamin's theorems. Okay, and we have based on that we have discussed some few problems also. Okay, now in conclusion with that, now in this video lecture we are going to discuss again some few more additional numericals of that cylinder problem, okay, which are very much useful from your final examination point of view. Okay, so just see one by one. We have completed up to the problem number 5. Okay, yes, 5. Okay, now next is problem number 5 on 4. Okay, now see the problem number 5. Okay, 2 ropes are tied together at point B as shown in figure. If the maximum permissible tension in each rope is 3000 Newton, what is the maximum force P that can be applied? Okay, so these are the two ropes, they are tied together at point B. Okay, this is the one additional force here. Okay, this theta is not given or given. Theta, what is asking the problem? What is the maximum force P that can be applied? This P has been asked. Okay, now we are to draw the free body diagrams. See, this is the 30. Okay, this alternate is this is 40. Its alternate is 40. This is 30. Its alternate angle is 30. Okay, now cut this rope and show it by tension force 3000. Okay, now this P has been determined and this theta is also not given. Okay, now see, this is 3 forces. All 3 forces are collinear, sorry, not collinear, coplanar, concurrent, and it is a pulling forces. Okay, means Lamin's theorem you are able to apply, but think over that. For the Lamin's theorem, this theta is not given. Okay, so unless and until we are not able to calculate this theta, we are not able to apply the Lamin's theorem. Okay, if this theta is given, then it's very simple. We can easily apply the Lamin's theorem. Okay, so here what we have to do for this, we have to use, since Lamin's theorem is not, we are not able to apply here, so we have to think the another options. Okay, so we have to go the second option by the resolution concept. Okay, so we have to resolve these forces P cos theta, P sin theta. This is 3000 cos 40, 3000 sin 40. This is 3000 cos 30, 3000 sin 30. Okay, now see here. Okay, so see now, apply summation Fy is equal to 0. First, P sin theta is vertical is P sin theta minus 3000 sin 30. It's this component downward direction, therefore minus, and again it is downward, so minus 3000 sin 40 is equal to 0. Therefore P sin theta is equal to 3428.36, equation number 1. Now apply second summation Fx is equal to 0. P cos theta, which is going right direction, P cos horizontal component, then minus 3000 cos 30 and plus 3000 cos 40 is equal to 0. Therefore P cos theta is equal to 299.94, equation number 2. Now it is there are two equations. Now P sin theta upon P cos theta, that become cos theta. So P sin, so we divide equation 1 by 2. Divide equation 1 by 2. We get theta is equal to 85 degree. Okay, you solve that and you calculate this. Okay, so P sin theta upon P cos theta become tan theta, and 3428.36 divided by 299, you will get some that, and calculate theta is equal to tan inverse of that answer. You will get theta, that is compared to 84.99 or 85 degree. Now after getting theta, put this value of theta either in equation 1 or 2, you will get value of P. Therefore put in 1, you will get P 3428.36 divided by sin 85. So your P is 3441.46 Newton. Okay, so this is the problem number 5. Now next problem number 6. Determine the magnitude and direction theta of a force P so that the particle is in equilibrium. This theta and F is where to determine. Okay, So first of all, calculate the theta, this angle, tan inverse of 4 by 3, it comes out to 53.13, and just solve it by the regular resolution summation fx, because again Lamin's theorem is not able to apply, though there are three forces, concurrent pulling forces, but this theta is not again known to us, so Lamin's theorem will not be is not able to apply. Okay, so just do the resolution. F cos theta minus 7 cos 53.13, and this only to this is the vertical force, no need to resolve, is equal to 0. Therefore F cos theta is equal to 4.2. Equation number 1, Fy is equal to minus F sin theta minus 3. This we have to take, it is vertically downward, so minus plus 7 sin 53.1 is equal to 0. Therefore F sin theta is equal to 2.6. Equation number 2. Now from equation 1 and 2 means again that F cos theta sin upon cos, divide equation 2 by 1, 2.6 by 4, therefore F comes out to be 4.94 and theta comes out to be 31.76 degree. Okay. Now next, see, the problems are very simple, but just you are able to apply you must know the equilibrium equations, you are able to properly draw the correct free body diagrams, and you know the concept of moment from unit number 1. Okay, now see, a force of 150 Newton acts on the end of a beam ABD as shown in figure. Determine the magnitude or tension in cable BC to maintain equilibrium. This is ABD. This is the one beam. This load is acting at one D point, 150 Newton load. This is B to D 8 meter and A to E is 2 meter. Okay, and there is a one cable is attached over here. This is one vertical wall, supports, hinge supports. Therefore you have two reactions, AX, AY, and you calculate this angle, tan inverse of 3 by 4, and replace this cable BC by a tension force. This is T, and this is angle 36, tan inverse of 3 by 4. Okay, and this distance is 3 meter. Okay, now what is asked in magnitude tension, with this tension force has been asked. Okay, so you have to take moment at the supports. So where is the support? Support is A. Okay, so take moment about A point. Okay, the moment is force into distance, and take clockwise moment positive, anti-clockwise negative. Okay, here what sign conventions here is used. We have to resolve this T cos 36. Okay, and it is creating a clockwise moment. Means he has taken clockwise as minus. Okay, doesn't matter, you take any sign conventions, just maintain the uniformity throughout the numericals, you will get same answer. Okay, so minus T cos, so if you are taking clockwise plus, here you will get plus, okay, into 3 this distance. Okay, now AX, AY passing through this, it's 0. Okay, now this vertical component, it is again creating a clockwise T sin 36.86 into 2 meter. This now for vertical component, this much is the distance, for horizontal 3 is the distance, and it is creating an anti-clockwise 150. So it is he has taken anti-clockwise as plus. Okay, so you have to take it as a minus if you are taking clockwise plus and anti-clockwise minus. Okay, so 150 into 10 is equal to 0. Therefore T is equal to 416.67. See how is the big problem look, how initially how it looks like very difficult. Okay, but you will get answer in only one single steps. Okay, for that just in first step you have to draw the free body diagram, second step take moment, in third step you will get answer, and this problem carry 5 to 6 marks. Okay. In engineering mechanics, except truss problem, all problems are not more than half page or at max 1 page problem. Okay, so only truss problem is lengthy. Remaining all problems are not too much lengthy, just you have to understand the concept properly, you have to solve the problem. Okay, now next problem, the 3 cables are joined at junction C. Where is junction C? This as shown in figure. Determine the tension in cable AC and BC, AC BC, caused by the weight of 30 kg cylinder. This 30 kg cylinder is there. Okay, now just draw the free body diagram, cut this AC, show by tension force, cut this BC, show by tension force, 60, 45 and 50. Okay, by Lamin's theorem. TAC divided by its opposite angle is 135, it's become 135, because if you draw perpendicular here, this is 60, it becomes 30. 30 and this is 90, 120 and this is 15, 135. Next 294.3 divided by sine 6 plus 60 plus 45, 105, and TBC is sine 120. TAC is equal to 215.44 and TBC is equal to 63.86 Newton. Okay, this is the answer. Then next problem, a mass raises a 10 kg joist of length 4 meter by pulling a rope. Find the tension in the rope and reaction at A. Tension in the rope, this is the rope. Okay, apply a drop free diagram. This is the free diagram. At A, there are two reactions. The rough surface, vertical horizontal is 45 degree. Weight of this bar at center 10 into 9.81, and this is the angle. It is 45 is complete. This is given as 20, so 10, 25, and this remaining is 20. Okay, so this is the FBD of joist. Joist means is a beam. Okay, beam or rod. Then apply, take moment at A. Where is A? This is A. Okay, so T sin 25 you have to resolve this tension. T sin 25 into 4 minus 10 into 9.81 into 2 cos 45. This is the distance. This distance is 2 cos 45. Okay, so T is equal to 82.07. Then summation Fx is equal to 0. HA, Fx means horizontal forces. Okay, HA minus T cos 20 is equal to 0. Therefore, HA is equal to 77.12. Now summation Fy is equal to 0. VA minus vertical forces. Now, so VA minus 10 into 9.81 plus T minus T sin 20 minus downward. Okay, is equal to 0. Therefore, VA is equal to 126.17. Okay, now therefore resultant reaction RA is equal to square root of HA square plus HV square. So RA comes out to be 147.37 and it's theta. Vertical, y horizontal, it becomes 58.57. Okay, now next problem. The rail AB of a foundry crane is horizontal and is 20 meter long, and A is hinged to vertical wall and end B is tied to a tie rod BC, making an inclination of 30 degree with the rail. The other end C of the rod is connected to wall. If a load of 400 Newton is placed on a rail at a distance of 8 meter from end A, find the tension produced in the tie rod and reaction developed at end A. Okay, so see, this is the figure. Okay, again the first part is freeboard diagram. So, okay, this is vertical, one is hinge. Hinge means A is hinge. So here there are two reactions, vertical, horizontal. This the rope or what is mentioned in the problem, it is B and B is going to tie rod. This tie rod means we have to cut this tie rod, and since the tie rod is always under tension, cut this and show by tension force. Okay, this is 30. Okay, so we have to resolve T sin 30, T horizontal, T cos 30. This is 400, this is 12, this is 8. Okay, and what is asking in the one, tension producing the tie rod and reaction developed at end A, means VA, HA and VA has been calculated and T has been calculated. Okay, so first take moment at A. Here we are taking moment, so this is clockwise plus 400 into 8 meter. See, he has taken minus. Okay, again I am repeating, it is a problem of sign conventions. I am normally using clockwise plus, here is clockwise is minus. Okay, so it is 400 into 8 minus T sin 30 into 20. Therefore, T is equal to 320 Newton. Now apply summation Fx is equal to 0. HA minus T cos 30 is equal to 0. Therefore, HA is equal to 277.13. Now next summation Fy is equal to 0. VA minus 400 plus T sin 30 is equal to 0. Therefore, VA is equal to 240 Newtons. Positive means it is going upward direction, and it is right means it is plus means going in right direction. If it comes negative, it goes in left direction. Now resultant reaction square root of HA plus VA square 366, and its direction theta is equal to tan inverse of vertical by horizontal. It comes out to be 40.89 degree. This is the next problem is, if rope BC fails when tension becomes 50 kN, determine the greatest vertical load F that can be applied to the beam AB. Also determine the reaction component at A. See, this is the A support hinge. There are two reactions, vertical and horizontal. This is F and this is tension, BC. What problem says that when tension becomes 50 kilonewton, when the tension in this cable becomes 50 kilonewtons, rope BC fails. Okay. So determine the greatest vertical load F. This F you have to determine. Okay, so we have to put this T as a 50. Yes, this T, draw the FBD. This is T 30. This 26 incline. We have to resolve this. So take moment at A is equal to 0 minus 26 sin 60 into 2 minus F into 6 plus 50 sin 30 into 6 is equal to 0. Therefore F is equal to 17.5 kilonewton. Fx is equal to 0. HA minus 26 cos 60 plus 50 cos 30 is equal to 0. Therefore HA is equal to 30.3 kilonewton. Now Fy is equal to 0. VA minus 26 sin 60 minus F plus 50 sin 30 is equal to 0. Therefore V is equal to 15.02 kilonewton. Next is the L-shaped member ACB is supported by a pin support at C and by an inextensible cord attached at A and B, passing over a frictionless pulley at D. Determine the tension in the cord and the reaction at C. See, first of all, draw the free body diagram. FBD of member ACB. This is the ACB. See, A, C, B. Here there is a tension. This tension is in balance. Here there is a 110 node. It is a hinge. So here are two reactions. Okay. So first take moment at C. At support we are taking the moments. So T into 400. T into 400 minus T into 300. I am not repeating now sign convention. So you use whatever you want. Either take clockwise plus or clockwise minus. Okay. Doesn't matter. T into 400 minus T into 300 minus 110 into 400 is equal to 0. Therefore T is equal to 440 Newton. Always mention the unit. If it is in Newton, mention it in Newton. If it is in kg, mention it in kg or convert it in Newton. Multiply kg into 9.81. Summation Fx is equal to 0. That is T plus Hc is equal to 0. Therefore Hc is equal to minus 440. Summation Fy is equal to 0. Vc plus T minus 110 is equal to 0. Therefore Vc is equal to minus 330 Newton. Resultant reaction is square root of Hc square plus Vc square, which is 550 Newton. And direction theta is equal to Vc by Vx, that is 36.87. Now next problem, determine the reaction at A and B for the member ACB loaded and supported as shown in figure when alpha is equal to 30. Now see, this is the inclined roller. Okay, so we have discussed when we have discussed the types of support at roller. There is that reaction is always normal to the plane. Okay, so it is normal is RP. Okay, but that we have to resolve. This becomes RB sin 60, RB cos 60 is alpha. This becomes alpha, alternate angle. Okay. So take moment at A, summation AB is equal to 0. RB cos 60 into 250 plus RB sin 60 into 500 minus 330 into 250 is equal to 0. Therefore RB is equal to 147.85 Newton. Summation Fx is equal to 0. Now HA minus RB into cos 60 is equal to 0. Therefore HA is equal to 73.92 Newton. It coming positive, which is going right direction. Now summation Fy is equal to 0. VA minus 330 plus RB sin 60 is equal to 0. Therefore VA is equal to 201.96 Newton. It is positive. Now resultant reaction, square root of HA square plus VA square, that is 215.06 Newton, and its direction theta is tan inverse of vertical by horizontal, that is Vy by Vx. Okay, so it becomes 69.90. These are the common steps you have to first follow. Okay, three equations of equilibrium: summation fx0, summation fy0, and moment 0. Apply as per the requirement. Okay, then calculate the resultant reaction and its direction. Okay. Now next, two identical rollers, each of weight identical means similar weight, okay, of each weight 445 Newton, are supported by an inclined plane and a vertical wall as shown in figure. Assuming smooth surfaces, find reaction induced at the point of support A, comma B and C. Okay, see, this is the situation. Okay, vertical wall, inclined wall, these are the two cylinders, 1, 2. This is 30 degree. This is A surface, B surface. Okay, so here there is a contact reaction, here there is a contact reaction, at C there is a contact reaction, and two are connected here. So here the one common reaction comes. Okay, now see the pre-word diagrams. Okay, so this is first cylinder. Okay, first this is one reaction, second reaction, and third is self-weight. First reaction, normal reaction at C, it is normal reaction. This is self-weight, and there is a common reaction R, which is common in both the cases. Okay, and for second, it is common reaction. This is the normal reaction at A, and it's self-weight 445. Okay, now for do the analysis for ruler 1. Which one we use first? Solve first, either 1 or 2. Yes, just think. For ruler 2, if we are using and analyzing 2 first, so what will be here? 445. This is R is unknown, this is unknown. Okay, yes, here we have to analyze second first, because this R we must know. Okay, and here there are 2 forces, here there are only 3 forces. Okay, so this out of these 3, 1 is known, that 2 can be determined by using Lamin's theorem, but here Lamin's theorem is not applicable. Okay, so that this R must be known before analyzing the first one. Okay, so for roller 2, see the video of second roller. Use the principle of transmissibility. This has been shown like this has been like this, and this has been like this. Okay, see this figure. Okay, so apply the Lamin's theorem to this. R divided by what? Sin 150. This R, its opposite angle, this is 90, this is 160, is equal to 445. This is weight, its opposite angle is 90 degree. And next is RA, which is RA. This is 120, 90 plus 30. Okay, therefore R is equal to 222.5 and RA is equal to 385.38. Okay, now this R will be required to analyze the roller 1. Okay, now see the diagram of roller 1. This is RC, which has been shown like the by transmissibility force RP, self-weight of the cylinder, and this is common reaction R. Now here Lamin's theorem is not applicable because here there are 4 forces. Okay, so we have to go by the second option, that is the resolution. So summation fx is equal to 0, RC minus RB cos 60 minus 225.5 cos 30 is equal to 0. Equation 1, summation fy RB sin 60 minus 222.5 sin 30 minus 445 is equal to 0. Okay, now substitute the equation, therefore RB comes out to be 642. Here RB can be determined. Okay, so RB is 642. Put value of RB in equation 1, you will get RC 513.84. Okay, the same problem can be analyzed by these also. Okay, after that I will provide you this copy. You can think about it and you can try to solve it by your own. Okay, answers are here. Okay, you will get same answer. Okay, now see another problem. 2 spheres P and Q, each of weight 50 Newton and a radius of 100 mm, rest in horizontal channel of width 360 mm as shown in figure. Determine the reaction at point of contact A, B and C. Okay, this is the channel, this 2 width. Okay, so see where is the contact surface for P. It is here normal reaction at point B, at point A, and here there is a common reaction, and for Q at point C, and self-weight of P and Q. Okay, so see its pre-word diagram. First of all, see this one. Okay, channel AB, this is 100, this is 100, and this is 160 because total width is 360 and its radius is given, radiuses, this is 100, this is 100. Okay, both are having same radius. This is 100 because for this it will require theta. This theta we have to calculate here. Okay, so in triangle PMQ, this has been considered as a triangle PMQ, and cos theta is equal to 36.87. Okay, because this is 100 and this is 160. Okay, and now see the pre-body diagram. This is weight RA at contact surface, RB at contact surface, and this is the common reaction. Now here only common reaction, weight, self-weight of cylinder, and normal reaction RC. Okay, so now we have to analyze Q first, because here there are three forces and one is known, so other two can be determined. Okay, so for Q, R upon sine 90, this is R upon sine 90 divided by 50 upon sine 180 minus theta is equal to RC divided by sine 90 plus theta. This theta has been determined. We have determined this 36.86. So put that value, you will get R is equal to 83.33 Newton and RC is equal to 66.6 Newton. So use this common reaction R in the second cylinder P. Okay, similar to the previous one. Okay, now here there are four forces. Use resolution, summation fx 0 minus r cos theta plus r is equal to 0. R is equal to 66.6, Fy 0, R is equal to 1000 Newton. Okay, so this way you have to solve the problem. Okay, next, three identical tubes of weight 8 kilonewton each are placed as shown in figure. Determine the force exerted by the tubes on the smooth walls and floor. These are the three cylinders 1, 2, 3. Okay, now Lamin's theorem. This is the diagram. Okay, so this is the common reaction, common reaction and self-weight. Okay, this angle this become 30 and this become 90, so 120, 120, 120. So this will be the pre-body diagram. Okay, so first of all calculate its reaction. So 8 upon sine 120 is equal to R upon sine 120, so R is equal to 8 kilonewton. Okay, now use these are the two, either consider these or these. Okay, so here we have considered yes, RW is here, reaction from here, wall reaction, subfloor reaction, self-weight, and this is the common reaction we have determined earlier. Now, here Lamin's theorem is not applicable. We have to determine it by there are four forces 1, 2, 3, and 4. Okay, we have to use here the resolution. Okay, so make a correction here. So here comes out to be RW 6.92 and RF is 12 kilonewton, not 4. Okay, so that we have to do. See, sometimes there is a mistakes in the books also. Okay, so when you are able to identify the mistakes in the books, it means that you are going in a correct way. Okay, sometimes what is happening, there is a mistakes in your notes or any textbooks, and you are continuously thinking on that and you are losing your times. Okay, because actually there is a mistakes and you are not able to identify that one. Okay, and you are confusing yourself that I am not able to understand these problems. Okay, due to the mistakes of the books. Okay, so that's why I always refer to standard textbooks. Okay, where there is a very minimum chances of the mistakes. Okay, next is three cylinders are piled up in a rectangular channel as shown in figure. Determine the reactions at point 6 between the cylinder A and vertical wall of the channel. Okay, so these are the three cylinders A, B, C. Okay, we have to draw the pre-body diagram. See, this is first R1, R2. Where is R2? R1. This is R3, R5, R6. So then 2 is here. This is R2, and this is R4. Okay, this is the common contact between B and C, and here there is a common contact between A and B. Okay, so draw the FBD of entire this and use that this you have to determine from the geometry. Okay, you understand, observe it carefully, draw its pre-body diagram, and you will get this theta. Okay, cos 8. This is the radius of this, and this is again 10. Okay, this is 8 and this is 10. Then use summation Fy is equal to 0, 20 into 9.81 minus 14 into 9.81, so you will get R5 is equal to 735.75. Now consider a cylinder A. Where is cylinder A? This one. Okay, and resolve that. Summation Fy is equal to, you will get R4 is equal to 91, and if Fy is equal to 0, you will get R6 is equal to 784.8 Newton. Okay, so this way you have to solve the problem. Okay, so as a time being, I am going to stop here because we are almost reached to 30 minutes. Okay, so if our length of video exceeds more than 30, it will be a slightly monotonous for us. Okay, so I am going to stop here, and whatever part is remaining for unit from unit number 3, that I am going to cover in the next video lecture, that is video number 3. Okay, so thank you all of you.